Coming up next on the IP Talk stage, Brian Gardner from True Circuits presenting analog timing IP for your digital chips.
All right, so I'm from True Circuits, and I'm just going to talk a little bit about timing IP. You got to put a chip together, and you're probably going to need some clocks. And you know, our tagline, I think, is timing is everything, or we had another one, analog timing for digital chips. I like a couple of other taglines. I like sort of easy decisions, so we want to make things easy. Not many things are. One of my other good taglines is, you got money and we want it. So anyway, we're here to solve some problems. And I noticed at our booth, there's hardly anybody coming by saying, you know, things are just too easy, and I want a little bit more complicated task to do. I'm having too much, it's too easy to find IP, it's too available, it works in every process, and I need more to do so I can justify my job to my boss. So anyway, we've been around actually since 1998. Even though we're still a relatively small firm, we're one of the pioneers in hard IP. We put the hard in hard IP. We're mostly located in Los Altos, not very far from Stanford. We have a number of a very experienced team of people. We're not only all about just putting together analog IP, but we're all about a very powerful system of automation to produce and characterize IP. So at the end of the day, what we're trying to do is we're trying to be a product provider. And if you look at the IP space, it's really kind of divided into more service providers and product providers. And in mixed signal IP, even more slanted towards service providers. That's good, you need that. In some cases, you need a special piece of IP. You don't have the team to do it, you need services. But more and more, as engineers are able to design around standard blocks, they need stuff that's a product. They need something that's productized, that's flexible, that they can't touch. And actually, if your engineering managers want things that engineers can't touch, and build it as a product. And that's what we're trying to do. So we're able to use automation to build PLLs and DLLs and timing IP that is flexible, that will automatically be ported to any process, any metal stack, any oxide thickness. It looks the same at 0.13 micron as it does at 28 HPM. As you migrate from process node to process node or from foundry to foundry, you got the same look and feel, you got the same front end view. And we're using a lot of automated technology behind it to be able to produce those kinds of things and build something that's easy to use. I mean, honestly, our average customer spends about 2 hours with us in post-sale support. Very easy, delivered as one single hard macro. The decoupling caps, the isolation rings are there. It's really pretty easy to use, and that's what we're trying to do, because there's too many other hard things to do in this space. I didn't pass anything, did I? Nope. So the main products we sell, timing IP, they're PLLs and DLLs. So sort of our average customer, our average engagement looks like somebody that needs clock generation to run their CPU at, let's say, maybe a gig. Maybe they have a DDR interface that needs a 533 megahertz clock for a PHY they're going to build, or maybe they have a 100 megahertz reference clock that goes into a SerDes, needs to be really low jitter. And that's the kind of thing we excel at. We have a very piece of flexible IP. You can use it for many different clock jobs, or you can instantiate it several times across the die. It doesn't cost any more. Program it a little bit differently. And what used to look like 2 or 3 separate pieces of IP, sort of the history of DLLs or PLLs is more like, I designed something to do this, I designed something to do this, and I designed something to do this. Here you got the same thing, you program it. And you know, it takes what had been a fairly hard job and turns it into something that's pretty simple. We have many different kinds of PLLs. We have clock generation, we have spread spectrum, which spreads the clock over a frequency range and reduces the emitted RF, which is important if your product has to pass a FCC. It's programmable. Spread spectrum robs from your performance, so you can program, you know, however much performance degradation it takes to pass the FCC testing. We also have low bandwidth and D-skew. We have DLLs, which are delay lines, very precise analog delay lines. Most of those currently go into DDR memory interface IP, where you have to delay some signals, you have to match some skews. But increasingly, people that are using faster off-chip parallel interfaces will use the DLLs to match up all the skews. We've gone in about 70 processes in the time that we've been in business. True Circuits, we believe we've been in about 1,000 tape outs, and probably we have the wafers, but not the units. Probably about 2 billion units. So, as far as silicon proven, I mean, 2 billion units, 1,000 tape outs. That's pretty good. That's about as much as anybody has. We work with ARM. Most of the ARM processors have our PLL on them. They use them to validate the CPUs and also to ship emulation wafers. Our IP is very low jitter, very process tolerant. In fact, the architecture that we use, not only the automation, but the self-bias architecture we use is relatively insensitive to PVT. So it allows you, to be able to put it in a noisy environment, or more importantly, not have to work quite so hard at integrating. Maybe you just, you just bring the lines out. All of our PLLs, in most cases, run off core voltage, so the hookup is relatively straightforward. And again, highly programmable. So because we build a product, we build something that is flexible in its programming, instead of the flexibility that arises today of redesigning or redoing the GDS2. That's very important. We've been doing this a while. I'll go into my Texas. This ain't our first rodeo. I don't know how to translate that in any other language, but this ain't our first rodeo. So we've been doing this a long time with a lot of different customers. In the old days, with people that had their own proprietary processes before the world more or less went fabless. And we've just finished off pretty much all of our 28 nanometer work. We have 5 test chips that are either tested or almost tested. So just about anything you need in 28 nanometer, all of our IP, most all the processes, Global Foundries and TSMC is ready. And then we're right in the middle of embarking on 20 nanometer. So whatever you need, we'll probably have it. As far as business model, just in keeping with the theme, we try to make it easy. We just charge a license fee. We don't charge royalties. We actually don't charge extra for support. You get the support with the product. Our licensing, our business model and our licensing agreements have grown up over the years to be relatively easy. So again, we want to make it easy on the engineers. We want to make it easy on the business people. We want to make it easy on everybody. Again, you got money and we want it. We work very closely. We have a number of ways to get our product to market. We talked about Chip Estimate here. So that's a really good way. You can go on the portal. You can find out what's available. You could look at our customers if you have our competitors, if you have some extra time you want to waste. And you can do that. We also provide a great deal of our IP through channel partners, through ASIC vendors. So if you're one of those companies that you don't do your own back end, maybe you design the front end, but you use an ASIC provider, we work with just about all of them. We have long-time relationships. We have, the business model that we have fits really well with ASIC providers because they're looking for things that are easy. They have way too many hard things to do. We work closely with the foundries, probably not so much in the channel piece, but sometimes. Increasingly, the foundries will be a good way to find out what's available. TSMC now has a certification and is a growing QS9000 program. So you can go to them and not only find out what's available, but find out what's been qualified through their fairly rigorous guidelines. And then, of course, we have sales reps and distributors pretty much everywhere. So there's a number of ways to get to us. And again, whatever's easiest for you. But in all cases, the products are the same. So you're going to get the same products. They're going to be packaged the same way. They're going to be supported the same way. We provide direct support with any of those models. So in summary, why do people choose us? Because we're easy. That's really the key message, easy. I like that. Well, IP is really hard to do, you know. All these guys come and they go, you put together, especially the ASIC providers, the customer, they put together this whole, okay, well, I've got all 15 pieces of IP. It's all ready. I've got it all figured out. And then the customer goes, I'm going to change the metal stack. And then, it's like a trap door. Boom, 2 pieces drop out, and it's like, it's back there. And then the customer goes, we might just go ahead and go to 40 nanometers instead of 65, and gets it all the IP back again. Hey, we decided LP. 2 or 3 pieces fall out. So really, that's where the automation and what we do is important. We guys, don't worry about it. Whenever you're ready, just tell us what you want. We've got it all. Fill in the order form, and you're there. And again, see, John, our president's back there. He's our president and our chief technical guy. So I always say John he's half analog circuit genius and half computer science genius. So really and truly, the automation that we use is a huge part of our success. It's not just people that brilliantly draw circuits, but people that brilliantly draw circuits that can be adjusted for all the different processes at a higher level of abstraction than pushing triangles. We use that exact same automation for characterization. So our lab is fully automated. We run through voltage, temperature. We move the chamber up. We take thousands of millions of measurements. So layout, front end, back end. We have our own tools. So we can run 300 plus processors when we want to do Monte Carlos. So we can do hundreds, sometimes even thousands of corners, so that you're doing a very, very thorough pre-silicon valuation, and then you're doing a very, very powerful post-silicon valuation, and you're making sure the two match. So you got a closed loop. Very large portfolio. If you go to our website and look at our portfolio, you'll really get tired of scrolling down because we have just pretty much every process available. We've been working with, the foundries for a long time. Many of our customers are the largest customers of the foundry, so that close relationship's really important. Good people, a lot of impressive list of folks, and a long track record. And we're easy. Okay, you guys got money, we want it. Any questions? Sean's not paying attention. He's going to ask me a question about jitter. Why is jitter important? Do the Terminator.
Do the Terminator. Let me tell you, Brian. What are you doing with the jitter? Why is it so important? Yeah.
What was that I saw? Were you with the maid? What was going on there?
I just want to know where Maria is.
Yeah.
We're here in the great state of California with Brian Gardner. We're pumping everyone up every day. And we're doing this and that and things of that nature. And that's what, True Circuits is doing with the PLLs and the DLLs. Yeah, right.
Brian and True Circuits. We like to have a little fun here because it is good.
Because it's Wednesday afternoon.
It's a Wednesday. Yeah.
Everyone's ready to go home. And a couple of people are hungover.
No one knew that we actually had a sideshow business here, too. Not only do they do IP, but we're in the entertainment industry as well. Actually, I have a question for you. Your IPs are in a number of applications, a number of interesting consumer electronics applications. Could you just share a few?
Share a few.
Yeah. The gaming industry.
Yeah.
The mobile device. I mean, heavily. Into a lot of the products that your kids play with right now.
Yeah, pretty much. If you everywhere you need a clock. So, we have IP that's well suited for low power applications. We have a lot of IP that goes into really high end stuff where you need not only quick or fast clocks, but you also need low jitter, or a lot of these interfaces need very specific or tight requirements. Things like audio and video, the jitter in the clock manifests itself in a little bit different way. And so what seems small in one application is important to another. So one of the things that we really like to do is when customers will call us, they'll say, I need a PLL that does X, Y, Z. We go, okay, just hang on for a second. What's the application? And sometimes you get a little pushback. I got pushback from some guy. Go, why do you need to understand how I'm going to use it? It's like, because I want you to be successful. It's like, well, no IP suppliers ever wanted me to be successful before. They were mostly concerned that it just met. I said it would meet Spec A, and it met Spec A. And the fact that your product didn't work is not my problem. In fact, you owe me a reuse for the next time you use it. But no, we really do try to understand it. So we ask a lot of questions about how it's going to be used. What are you going to do with it? We try to spend some time with people. If you're going to connect our clock to a SerDes or to an analog front end, we try to understand that, maybe even work with some of the people in the industry to make sure we've already connected, it's going to be okay.
No?
I don't really have any good sexy applications.
Well, I think
came to mind, but they probably were things I shouldn't talk about.
I know. That's a whole nother convention. And it's in L.A., too.
I bet it's a lot more fun than this.
Well, we're getting good, aren't we?
Oh, yeah, right.
All right.
Maybe